Hyperloop is like a super-fast, futuristic train system that could zip people or stuff between cities at speeds up to 700 miles per hour. That's faster than most airplanes. It was first dreamed up in a big way by Elon Musk back in 2013, but the idea builds on older concepts from the 1800s. Think of it as a mix between a bullet train, a vacuum cleaner, and magnets from your science class. It's not fully built yet. Companies are still testing it. Imagine a long, sealed tube like a giant straw that's almost empty of air inside. Small pods, like capsules, carry passengers or cargo and shoot through this tube on a cushion of air or magnets. No wheels touching the ground, no bumpy ride. The goal? Get from Los Angeles to San Francisco in about 30 minutes instead of hours by car or train. It's eco-friendly too, running on electricity, maybe even solar power. Physics is all about forces, motion, and energy. Hyperloop uses clever tricks to beat the things that slow us down in normal travel, like air and friction. Here's the key stuff. Normally, when something moves fast, like a car or plane, air pushes back against it. This is called drag or air resistance. It's why you feel wind blasting your hand out a car window. The faster you go, the stronger the drag, and it takes tons of energy to fight it. Hyperloop fixes this by sucking most of the air out of the tube, creating a near vacuum, like space but not quite as empty. With barely any air molecules to bump into, the pod faces way less drag. Remember Newton's laws? The first one says objects keep moving at constant speed unless a force acts on them. In a vacuum, there's almost no force from air, so the pod can zoom along without slowing down much. It's like sliding a hockey puck on super smooth ice forever. Regular trains have wheels rubbing on tracks, creating friction. That heat and wear that slows things down and wastes energy. Hyperloop pods float above the track using magnets. Magnets repel or attract each other, like how two north poles push apart. Hyperloop uses electromagnets to lift the pod off the track by a tiny bit, maybe an inch. This is called magnetic levitation, or maglev for short. No touching means no friction, so less energy lost to heat and smoother rides. To move the pod, Hyperloop uses electric motors along the tube. These are linear induction motors, like a flattened-out version of the motor in an electric car. Electricity creates magnetic fields that push or pull the pod forward. It's like a slingshot. A quick burst accelerates the pod to top speed, then it coasts most of the way because of low drag and friction. Acceleration could feel like a roller coaster takeoff, maybe 1-2 times Earth's gravity, 1 to 2g, but not too crazy. To stop, it reverses the magnets or uses air compressors to gently slow the pod. Physics here is about converting kinetic energy, motion energy, back into other forms, like electricity. Hyperloop isn't just physics, it's high-tech engineering. The tubes are made of strong steel or composites, super light, tough materials like carbon fiber. They're sealed and pumped to low pressure using big vacuum pumps. The pods are sleek capsules holding 20-40 people with comfy seats, Wi-Fi and life support, oxygen since it's low air. They have batteries or get power from the tube. It runs on renewable electricity, maybe solar panels on the tubes. Computers and sensors, like in self-driving cars, control everything: speed, spacing between pods every few seconds, and emergency stops. AI helps route them efficiently. In short, Hyperloop is super fast, uses less low energy and causes less pollution, but it is unproven at full scale. If it works, it could change travel like airplanes did 100 years ago.